For the last 10 videos or so, we have been doing examples of how to do a proof, layouts of a proof. This one is another if-then proof, which is a conditional one, and it's for complementary angles. Do you remember what complementary angles are? It's when they get together and they make 90. Okay, so I'm going to step back and I'm going to see what we've got here. We've got our drawing like we should. We've got a statement now, an if-then statement. We've got our proof table with statements on the left and reasons on the right. We've got our given, which is our evidence, and our prove, the thing we're trying to prove. Okay, so let's take a close look at our drawing. Now, I didn't want to put the 1 and 2 in here, but I figured, you know what? Color coding it to make it easier to understand and putting numbers is going to make it that much easier to understand. You might see an example of something like this in your textbook or in a test, and you won't see the numbers. You're just going to have to deal with the WXZ and the ZXY. So I made it a little easier on you here. Okay, so here's our statement. If WX, the green one, is perpendicular to XY, the horizontal one, then this angle WXZ is complementary to ZXY. Saying 1 is complementary to 2. Well, if you know the reason, if you know the rule of two angles being 90 degrees being complementary to each other, then you understand that this is a right angle and they are both complementary to each other. Why do we have to prove it? Well, in geometry, they teach you deductive reasoning, so they give you easy examples so that you can understand the reasons. So, here, let's look at our given, which was taken from the statement. In if-then conditional statements, the if is the given and the then is the prove. So if you ever are missing a statement and they want you to write one, you know that the if part is here, the then part is there, okay? So it's saying that the green one is perpendicular to the red one, okay? That's given. So we write that as our number 1 here. That's what we're going to start with. Now the given isn't always first. It goes where it makes the most sense. But in this one, we're putting it first. I'd say maybe 80 or 90% of the time they go first. Here's our thing we're trying to prove, that the measure of angle WXZ is complementary to ZXY, that the measure of angle 1 is complementary to the angle 2, okay? So, because we know that these are perpendicular, we say that the green one and the red one form a right angle because of the perpendicular lines form right angles rule property, okay? So this is where your properties, theorems, principles, postulates, and definitions go to give reason why you're saying these statements, okay? So, because they're perpendicular, we know they make a right angle, because perpendiculars form right angles. The measure of WXY, the green and the red one, equals 90 degrees. Why? Our reason? Because right angles have a measure of 90 degrees, okay? Then we say that the measure of the green and the red one equals the measure of 1 and 2 combined. And our reasoning is the angle addition rule. Then we say that the measure of 1 and the measure of 2 is equal to 90 degrees because of the substitution property. So then we say the measure of WXZ is complementary to the measure of ZXY, the thing we're trying to prove, comes down here, and our reasoning is complementary angles equal 90 degrees. We have proven that they both have 90, together they make 90 degrees, so we've proven, because of the complementary angles property, that rule, that they make 90 degrees. So, to reiterate, it means that we had evidence that the green and the red one are perpendicular, because perpendicular on the angle is a right angle. Right angles are 90 degrees. The right angle is equal to two smaller angles that make it because of the angle addition rule. Angle 1 and angle 2 make the right angle because of the substitution property. The first angle is complementary to the second because they equal 90. So we have now proven what we were trying to prove, and we did it with an if-then, which is called a conditional statement. Our next video, number 50, is going to be about polygons and open and closed polygons.